microbes only. But that's not too much of a disappointment, because almost all life on Earth, almost all known life, is in fact microbes. There are many more microbes than human beings, for example. And in fact, if you count the number of species, and you already saw the tree of life, almost all of those branches on the tree are microbial, bacteria and archaea. So microbes dominate the tree of life. And multicellular organisms, we notice because they're big, but they're just really a tiny perturbation. So the question is, among all those microbes which are teeming in our environment, could there be some which are life but not as we know it, in which the biochemistry of these microbes is so different that it could not have had a common origin with life that we know? And you can't tell by looking what a microbe is made of. You've got to dig into its insides and study its biochemistry. And the techniques which microbiologists have perfected for culturing and then sequencing the genomes of microorganisms are all customized to life that we know. And of course, if you go out and look for A, you'll find A, you won't find B. So if there are microorganisms with a very different biochemistry, or even slightly different biochemistry, chances are your lab techniques will not work. And so if 1 in 1,000 microbes in a cubic centimetre of soil are a form of life that we don't yet know, we could very easily have overlooked it. So the question is, what are we going to do? If the shadow biosphere is there, how do we identify its inhabitants? How do we work out where these alien microorganisms might be? Well, there are two real possibilities. The easiest thing is if these microbes are so different from known life that they can exist in harsh conditions beyond the reach of life that we know. And so these would be ecologically separate. There would be certain places where life as we know it exists, and other places where this other life 2.0 would exist. Harder, but more likely in my view, is if they are ecologically integrated. I'll come back to that in a second. Let's have a look at ecologically separate. We've already heard about the deep ocean volcanic vents, the extraordinary organisms that live there at temperatures above even the boiling point of water. Amazing, the normal boiling point of water. But when you sequence their genomes, they're on the same tree of life as you and me. So these are not life 2.0. They're just a rather extreme form of life 1.0. However, there are undoubtedly limits. Nobody knows quite what the temperature limit of known life is, but the answer seems to be around about 130 degrees centigrade. We know of some organisms that can not only survive but thrive at around about 123 degrees centigrade. But supposing there's a cutoff at about